Star-forming regions are some of the most visually striking parts of the night sky. Within these regions, perhaps the most spectacular stellar fireworks are the jets of matter that shoot out from newborn stars. Now, scientists have used Hubble to watch these jets move, giving new insights into how stars form. The NASA ESA Hubble Space Telescope has made detailed observations of the energetic jets that are ejected from young stars. Astronomer Patrick Hartigan and his team have been collecting high-resolution Hubble images of some of these jets for the past 14 years. The team have now combined their observations into movies that actually show how the jets evolve over time. Unlike most astronomical phenomena, which look completely static even over hundreds of years, these jets visibly change over human timescales.
Well, my first reaction is, wow, this is really neat. And it was just really fun to see all of the dynamics that's going on, because when you just see a single picture, you can kind of make up all sorts of stories, but all of a sudden when you see a movie stitched together, it completely changes everything. You really see what's happening. If you see just a single picture from Hubble, you can interpret it in many different ways. But the fact that Hubble has been around for as long as it has been means by taking multiple images, you can actually stitch them together and watch how the material moves. And so that really gives you the only way to get true insight into the physics of the dynamics of what's going on.
Some of the details in these jets had never been spotted before. For instance, the knots of gas brightening and dimming over time, and the collisions of fast and slow-moving material show that these jets are not ejected in a steady stream. Rather, they are launched sporadically, in clumps. Astronomers think that the irregular structure of the jet is caused by material periodically falling onto the star.
We're trying to study how stars form, and that's a complex process because it has a lot of feedback in the sense that the stars affect the clouds and then the clouds form the stars. And just by looking at any particular one process, you don't get the full picture. And so the idea is, what we want to try to do is to see the main ways in which the stars can affect the surrounding molecular clouds.
These jets are known to scientists as Herbig-Haro objects, in honor of George Herbig and Guillermo Haro, two astronomers who studied these outflows in the 1950s. However, it is only now that their complex nature is coming to light. As well as detailed Hubble observations, members of the team have carried out lab experiments and computer simulations in scientific facilities around the world, including New York's Omega Laser Facility and the UK Atomic Weapons Establishment. By combining observations, experiments and simulations, scientists can attack the problem of how stellar jets behave from three different perspectives.
The entire process is really very complex, and it's very important to understand because that's how our sun formed and that's how planetary systems form, and that's basically, how we got here. So.
The next Hubblecast will in fact be our 50th episode. To celebrate this occasion, we're asking you to tell us what you want me to talk about in that episode. So, send us your astronomy-related questions either by posting them to our Facebook page at facebook.com/HubbleESA or by emailing me at drj@spacetelescope.org. Full details are of course available on our webpage at www.spacetelescope.org.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The STScI highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.